All right, let's talk about carbs. You hear that word and you probably think of things like bread, rice, pasta, right? Well, that's part of the story, but it goes so much deeper. The real story is all about the science of sugar, and trust me, it's pretty fascinating. So let's dig in. To get us started, here's a little quiz for you. What do these three things, a slice of bread, a piece of fruit, and even a bottle of ketchup, what do they all have in common? Think about it for a sec. The answer might not be what you expect.
Yep, the answer is sugar. Or, to be more accurate, carbohydrates. See, sugars aren't just hiding in your candy bars and sodas. They're the basic building blocks for a ton of the foods we eat every day, from the super sweet to the surprisingly savory.
Now, to really understand carbohydrates, you kind of have to look at their family tree. The scientific name for them is saccharides, which comes from the Greek word for sugar. And just like any big family, you've got your simple single members, and then you have these huge, sprawling, complex branches.
So let's start at the very beginning with the simplest units of all, monosaccharides. Mono just means one. Think of these as the individual Lego bricks of the carb world. They're the absolute basic building block that everything else is made from.
And here are the two biggest celebrities in the monosaccharide world. On the left, you've got glucose. This stuff is the primary fuel for your entire body, especially your brain. It's essential. And on the right, there's fructose, which you probably know as the sugar that makes fruit taste so sweet. They look almost identical, but that tiny little difference in their structure, well, it changes everything about how our bodies use them.
Okay, so what happens when you take two of those single Lego bricks and snap them together? Well, you get a disaccharide. Di means two, and that chemical connection holding them together, that's called a glycosidic bond.
And here's a perfect example you already know. This is sucrose. We just call it table sugar. And if you look, you can see it's really just one glucose molecule bonded to one fructose molecule. That simple little pair is what you stir into your coffee.
And there are other famous pairs out there too. Lactose, which is the sugar in milk, is just a glucose linked up with another simple sugar called galactose. And maltose, which you find in things like molasses, that's just two glucose units holding hands. And finally, we get to the giants, the skyscrapers of the sugar family, polysaccharides. Poly means many. We're talking about long, sometimes incredibly complex chains of hundreds or even thousands of those little monosaccharide bricks all linked together. This is where you find starches and fiber.
Okay, science lessons cruising right along. We've got single units, we've got pairs, and we've got these massive chains. But so what? What actually happens inside your body when you eat them? How does your body turn something like a potato into pure energy?
Here's the most important thing to remember. Your body can only actually absorb and use those single Lego bricks, the monosaccharides. So it doesn't matter if you eat a complex starch or a simple sugar. Your digestive system has one main job: break it all down. It uses these things called enzymes that act like tiny molecular scissors, snipping all those bonds to free up the simple sugars your cells need for fuel.
Okay, get ready, because this is one of the coolest things in all of nutrition. On the left, you have starch, and on the right, you have fiber. Chemically, they are both just long chains of glucose. That's it. So why can we digest starch for energy, but fiber just passes right through us? It all comes down to one tiny detail, the type of bond. Starch uses what's called an alpha bond, and our enzyme scissors can cut it, no problem. Fiber, on the other hand, uses a beta bond, and our scissors just don't fit. We literally don't have the right tool for the job. So let's just lay that out side by side. Starch is digestible. It gives us energy because our enzymes can break those alpha bonds. Fiber is indigestible. It provides bulk for our digestive system, all because we can't break its beta bonds. It's just amazing that one tiny shift in chemistry completely changes how a food works in our body. So, once those carbs are successfully broken down into simple monosaccharides like glucose, they get absorbed into your bloodstream. And from there, they're whisked all over your body, delivering that quick energy your cells need to do their jobs. And you know who the biggest customer is? Your brain. It absolutely devours glucose. All right, enough with the molecular bonds and the chemistry. Let's bring this all back to the real world. Back to your kitchen, to your plate. How does all this science apply to the food we actually eat? This is a really important distinction to make. We have natural sugars, which are the ones that are just, naturally part of a food, like the fructose in an apple. They almost always come packaged with other good stuff, like fiber and vitamins. Then you have added sugars. These are the ones put into foods during processing. Think cereals, sauces, drinks.
Even if the source is natural, like honey or syrup, if it's been added to a product, it counts as an added sugar.
So how much is too much? Well, the World Health Organization gives us a pretty clear target to aim for. They recommend that those added sugars should make up less than 10% of your total daily calories. That's a great, simple rule of thumb.
So here's kind of what a balanced plate might look like on a 2,000-calorie diet. You can see the biggest chunk of your carbs would ideally come from those complex starches, with another healthy slice from natural sugars found in whole foods. But look how small that slice for added sugars is. In this example, it's just 5%, which is well below that 10% guideline.
So, what's the big takeaway from all this? It's pretty simple, actually. It's not about cutting out carbs entirely. It's about choosing the right carbs. The goal is to focus on getting your carbohydrates from sources that are packed with other nutrients, the fiber, the vitamins, the minerals you find in fruits, vegetables, and whole grains. You see, in the end, trying to label all carbs as either good or bad, it just misses the point. The real power comes from understanding the difference between them and using that knowledge to make conscious choices. So now that you know the science, what choices are you going to make?